Today we want to talk about cloud DevOps, right? So when we talk about DevOps, most people think this, which is it's a great way to connect the development and operations teams and bridge the gap. And yes, this is true, but DevOps is a lot more than just that. Ultimately, what DevOps can do is get your business more agility. And it can bring feedback from all of the downstream systems, including your customers, back into the development process so that you can build great solutions for your customers. So as we think about cloud DevOps at Google, there's 3 principles that we keep in mind. The first, of course, is how do we increase developer productivity? Because that's what we're all here for. The second bit, which is just as important, is getting all of that downstream feedback and shifting it left so developers have access to it earlier in the cycle. What this lets you do is avoid those costly mistakes and catch them much, much sooner. And the third piece, which is just as important, is scaled operations. What the cloud lets you do is run your business at scale, and cloud DevOps should enable that. So we're going to talk a little bit about each of these 3 aspects and then dive into a fireside chat as well in a little bit of time. So first, let's talk about how we increase developer productivity. As we talk to our customers, the number one thing we're hearing from them is, yes, they've looked at cloud as a way to lower their costs, but they want a lot more than just that. They want greater agility for their business. And the way they want to do this is by building cloud-native applications. There's been a huge surge of interest in this, especially around Kubernetes. Unfortunately, though, app dev teams across a number of our customers are still working on traditional IDEs that are optimized for local app development, those run on-premise. And one of the challenges with this is as you use these local environments to build cloud-native applications, you frequently end up with either more complexity or errors that are caught too late in the cycle. So to solve this problem, we announced Cloud Code yesterday. And what Cloud Code lets you do is rapidly build, debug, and of course deploy these Kubernetes applications. And the best part is you can do all of that right within the context of your local development environment. So think of this as a power boost to your IDE, and we've shifted left all of the complexity and we've abstracted it away so you can actually just focus on building cloud-native apps. So to tell you more about this, I want to welcome on stage Jez Humble, who's part of our developer advocacy team. Jez?
So, how many people in this room are building code in Node or Go or Java or Python? Okay, that's a lot of you, great. And how many people know how to set up and manage a Kubernetes cluster? Okay, that's also a lot of you, that's great. How many of you are going to be working on Kubernetes in the next year? Okay, almost everyone. So that's great. Kubernetes is the industry standard infrastructure for building cloud-native apps. But if you're anything like me, you might find Kubernetes a little bit intimidating to set up and manage. You might also worry about the impact on your productivity. My favorite experience as a developer is being able to hit save in the IDE, switch to the browser, hit refresh, and be able to see pretty much instantly what I did so that I can check that I'm on the right track. Microservices and service-oriented architectures also add complexity, and we want to create a simple way for you to stand up some subset of your production environment for development purposes locally. So today, we're going to show you Cloud Code. Cloud Code lets you develop code in VS Code and IntelliJ and get a seamless, near-instant developer experience that mimics what you're used to, that local developer workflow. So to show you that, we're going to build and deploy a simple distributed system. This is a guestbook, which is going to talk to a microservice that does translation of the comments in the guestbook into different languages. We're going to start off by building and deploying the translation microservices. And Dan Larenk here is going to show us what that looks like in Java using IntelliJ.
Thanks, Jez. Thanks, everyone, for coming. Everyone here has heard of terms like continuous delivery, continuous integration, continuous deployment. Today, I'm going to be showing how to use Cloud Code for IntelliJ to set up a continuous development loop where I can edit and save my code locally, and it's going to get deployed and running inside of a cloud Kubernetes cluster inside of Google Kubernetes engine. So right here, we have a cloud-native guestbook application. It's a very simple Hello World service that is written in Java and is printing out Hello World over HTTP. We can see that this is running in our continuous development loop. So it's running here inside of a remote Kubernetes cluster in GKE. We can refresh, see that we have the message. I'm going to come in here and change this message and press save. And this is where the continuous development loop kicks in. So we can see here below that Cloud Code is watching this code for changes, detected that I saved this file, and starts to automatically rebuild, repackage, and redeploy this up to GKE. So this code is turned into a container using our fast container builder called Jib, which knows how to optimally rebuild and repackage a Java application and get it running in a container registry. All right, so this should just be about to finish up here. And we can refresh and see our new message. So we were able to make this simple edit and get it running in GKE very quickly. This is the basic app, though. This isn't the translation backend that Jez talked about before. So to turn this into a translation backend, I'm going to first add some client libraries and enable some APIs so that we can use the Google Cloud Translation API. I'm going to do this using another feature of Cloud Code. We can come in here and add cloud libraries and manage cloud APIs. I'll click that. This is the translation backend. So I'm going to click here on Cloud Translation. And there's a feature here to automatically enable the API on GCP for us, so we don't have to leave the IDE. I'll click Continue. And this next dialog is a way to have Cloud Code automatically create a service account and secret so that you can talk to this API. Since we're running in Google Kubernetes engine, though, we don't need to use this. I'll click OK. And now Cloud Code has automatically added this dependency to our application, added it to our pom.xml, and started to rebuild and repackage this again for us. I'm going to switch this code out for our translation backend. And while that gets redeployed, I'll explain how this works. Here's the main function here. It takes in some strings over JSON on HTTP and first passes them to the translation API to detect the incoming language. Next, based on what language it is, we translate this to both English and German. And then at the bottom here, we do some debug logging to system.out. Awesome. This looks like it's about finished, and we can try it out here. So I have some text saved that we're going to send in as a translation. It's a couple strings. So a couple strings get passed in, one in English, hello world, and a sentence in German. We can see that these are both translated back into English and German. And the final cool feature is that Cloud Code automatically streams these logs from GKE back down to our IDE, so we don't need to go anywhere else to see debug logging.
So not only did it deploy into Kubernetes without you having to do anything, it also streamed the logs back into the IDE for you. And that would have been hard to do on your own. It's great stuff.
Awesome. Yeah, so we got this simple translation backend running. Now we're going to look at how to use this in a bigger distributed application.
Thanks very much, Dan. Woo! Yeah, live demoing is terrifying. So obviously, in a real system, we're going to have more than one service interacting. So now we've got our translation microservice live. We're going to build this guestbook and deploy the guestbook, which is written in Node.js. And Vijay Subramani is going to show us how to do that using VS Code. Take it away, Vijay.
Hi, this is the hi. Thanks, Jez. This is the guestbook application that Jez was mentioning, where users can add guestbook entries in a language of their choice. And we'll go ahead and integrate this with the translation service that Dan has built to display English and German translations for these messages. And I'll be using the Cloud Code plugin for VS Code. And I'll go through one cycle of the inner development loop, make 4 quick code changes, deploy them to the remote cluster, and troubleshoot if required. So the first change, I'll make it in the display template to add some style sheets that are required. Next, I'll go and add some placeholders for the English and German translations. Then we'll go to the app.js file and tell it that it can find the location of our translation service from the Kubernetes environment variable. Then we'll add the main logic to call the translation service for each of the guestbook entries. It's a straightforward loop. We'll add some error handling as well. And then finally, we'll publish the location of our translation endpoint. And then we'll go ahead and save our changes. And the continuous deployment has been monitoring for your changes. And once it's detected them, it's packaged them and sent it over to the remote cluster for deployment. And as you can see, the deployment has already finished. And let's reload this. So there you go. We have our English and German translations. That does not look like German. Does it, Jess?
Nein, das ist nicht die deutsche Sprache.
OK. So let's go see what's happening. So the logs that were in the remote cluster are streamed directly back into your IDE, so you don't have to go around hunting for them. So from the logs, we can see that the German messages are indeed coming back from the translation service. So that service communication is working fine. So must be something going on with our application. So why don't we just try to debug? Let's set a breakpoint here, and let's start our debugger. And the debugger attaches against the running process in the remote cluster. So let's go ahead and reload our application. Boom. The debugger breakpoint has been hit, and we didn't have to do anything. This is against the remote cluster.
That's amazing. So we're debugging using the regular IDE debugger. In the Kubernetes cluster, we didn't have to create any launch configurations, write any YAML, do any port forwarding. It just worked from within the IDE. That's awesome stuff.
And this is a fully featured debugger. You saw me stepping through it. You have the watch variables. You've got the hours. You can even inspect the variables. So from this, I can look at the temporary translations array that the code is building. And I can see that the German translation is reaching my application code. So maybe we're missing some kind of assignment statement somewhere. So let's go ahead to our debug console and hardwire one of these assignments and see if it gets reflected in our application. So we hardwired for one of the entries. So, oops, and let's let our debugger run through. And there we see the entry that we changed is being reflected in our application.
And once again, that's changing the state of the live system from within the debugger. Cool stuff.
So it looks like we're missing an assignment statement somewhere. There it is. So let's go ahead and fix it. And let's save our changes and stop the debugger. And Cloud Code would have picked up these changes and would have already started packaging them and started deploying to the remote cluster. And as soon as it finishes deployment, we can reload the page.
And obviously, the IDE takes its time, especially when there's a demo. That's a built-in feature. If you're demoing, it adds a special lag just to make your life difficult.
So it'll reload the page with the right entries. So what you just saw was one cycle of the inner development loop. We made some changes, we deployed them, we debugged them, and you didn't have to touch any Kubernetes configurations yourself. Cloud Code handled all that for you in the background.
Cool. Thanks very much, Vijay.
Back to you.
OK, so once you've got your service live in production, obviously you have a whole team that takes care of it. And Ben is going to be talking about SRE later on in this segment. So one of the key concepts of SRE is SLOs, or service level objectives. And these are targets for the health of your application that represent something a user would experience, not a proxy variable like CPU usage or memory usage. And once we have SLOs, what happens is our application breaks them, and we get woken up at 4 o'clock in the morning. So I've been woken up at 4 o'clock in the morning because our application has fallen below its SLOs, and I'm going to ping Christy Wilson, who is on call for this app, and she's going to work out what's going on so that we can remediate and get everything working again. Over to you, Christy.
All right, so it's 4 a.m., I'm on call, and I've been paged. I need to figure out what's going wrong in production and fix it as quickly as possible. So to do that, I'm going to use Cloud Service Mesh, or CSM. So CSM is currently in alpha, and it requires Istio. But out of the box, I can take a look at things about my running services, like the metrics. I can look at the logs. And I can look at other telemetry data as well. And I can create my own custom SLOs. So here we can see that I've already defined one for 95th percentile latency, and it's being violated. And since I'm looking at the front-end service, I have a pretty good guess that the reason I was paged is because the front-end service is overloaded. So I need to mitigate this as fast as possible so I can get back to bed. So to do that, I'm going to use Cloud Code. So Cloud Code can be used by all kinds of engineers, whether you're wearing your developer hat or your operations hat. And so what I'm going to do is I'm actually going to take a look directly at the production cluster in the Cluster Explorer. Now, obviously, not all developers should have access to this, but I'm on call, so I do. So in the Cluster Explorer, I can start looking at what's going on in production. I can see my deployments. They're all green. And I can start diving into individual pods. I can look at the containers in those pods. And I can see details like what environment variables they're running with, what the status is. And I can even get the logs from my production cluster right in my IDE. And if I want to, I can even connect a terminal and start executing commands in my production containers. So one thing that I'm noticing as I look at this is that our overloaded service only has one replica running. And since it's overloaded, I'm thinking maybe a way I can work around this is to increase the number of replicas. So to do that, I'm going to use this edit icon here, and I'm actually going to bring up the production configuration right in my IDE and make a change. So I want to increase the number of replicas from 1 to 10. But I'm tired, so I made a typo, and I put the value in wrong. But fortunately, the IDE has my back. So it's telling me, because it's aware of the schema, that the type is wrong here, and this should be an integer. So I can make the change I meant to. And because it is aware of the schema, the IDE can give me IntelliSense and show me what values are valid at this point in the configuration. So let's go ahead and save that. And the IDE prompts me to warn me that it's about to apply this live to a production cluster, which, yes, I did want to do. And in the Cluster Explorer, I can refresh, and I can see that Kubernetes is immediately doing what it does best and scaling out the 10 replicas that I requested.
So any ops people, SREs or sysadmins are probably having a mild heart attack at the moment watching Christy change the state of a live production cluster from her IDE. And in fairness, that wasn't a feature we'd originally planned. We got feedback from our early access users that they wanted this functionality. And in fairness, it's super useful if you're managing a dev cluster or a test cluster. It's really, really helpful. However, in real life, what we want to do is make this change to version control, push it out through a deployment pipeline. This is the paradigm known as infrastructure as code, or GitOps. So Christy, how would we do that?
Well, let's take a look at the files in version control. So this is the deployment in version control, and as you can see, because of my emergency change, it has fallen out of sync with production. So I'm going to make the change here. But before I do that, I can show you some other Cloud Code features. If you've been working with Kubernetes, you've probably noticed that you end up dealing with a lot of YAML. But having YAML support directly in your IDE can make that a lot less painful. For example, if I'm looking at this Mongo deployment and say I want to know what the value is of this secret, instead of having to dig around in the YAML in my repo and figure out where that secret lives, I can actually just peek at it directly and see what the value is. And these base 64 encoded strings, I can just hover over them and see what the plain text values are.
I just want to emphasize, Christy did not choose that password. Christy would never do that.
Yeah, I'm going to have some words with some people after this, I think. So what I'm going to do now is open the configuration and make the change to 10 replicas. So now I would commit this, push it, and open a pull request, and then Cloud Build would kick in, and it would do all the things that we want to do to properly land this change in production, like running vulnerability scanning, tests, etc.
Thank you so much, Christy. And so this is what it would look like in Google Cloud Platform in Cloud Build, seeing the builds that have gone through into prod from version control. So once we've got everything working again, we're going to go back to sleep, hopefully, and get up in the morning and work out what the actual problem was in the app that was causing that performance degradation. We can use Stackdriver Profiler to do that. Stackdriver Profiler is really powerful. Some of our customers have seen double-digit reductions in CPU usage as a result of using it, and it's generally available as of Tuesday. So today, we showed you Cloud Code. Cloud Code lets you develop, deploy, and debug your Kubernetes-based applications directly from within your IDE. And it doesn't just work against GKE, it works against any Kubernetes cluster, whether that's local, in a data center, another cloud provider. Cloud Code will talk to any Kubernetes cluster. You can download the code that we've showed you today. It's available in Node, in Go, in Java, and in Python. Start playing with that right now. We really hope you're as excited as we are about this powerful functionality, and we cannot wait to see what you do with it. Thanks very much for your time. Back to you, Pali.
Thank you, Jess. That was super exciting to see, and one of the great ways you can increase developer productivity while you're building cloud-native Kubernetes applications. So let's talk about the next thing, which is shifting left. And the purpose of shifting left, as we discussed earlier, is to help connect all of that downstream feedback to your developers and your development teams so you can catch those costly errors much, much sooner. This could be everything from enforcing coding guidelines to getting operational metrics earlier in the cycle. And of course, one of the most important things you want to do is catch those security errors very, very early in the process, because those can be really costly. To tell you a little bit more about how we're thinking about shifting security left and give you a practitioner's view of it, I want to welcome Mike Berry from ANZ on stage.
So, good morning, everyone. My name is Mike, and yes, I work at a bank. The ANZ Bank has been operating in Australia for the past 180 years, and every day we look after the details and information of millions of customers, and we look after billions of dollars of transactions. So, as you can imagine, security is very important to the way that we operate. Now, banking over those 180 years has changed considerably. It used to be about how secure your vault was and your branch, and that was security. But now we have more things to think about. In particular, today we're going to talk about security of our services and our applications as they're running in the cloud. Now, we have vulnerability scanning. So we're going to talk about two things. The first, vulnerability scanning. When you're running vulnerability scanning, the question is, how are you doing it? So today, do you have, in the audience here, do you have vulnerability scanning of some kind that you're running right now? Let's have our hands up. Yeah, we have. All right, we have vulnerability scanners out here. This is very good. My question is, when you run these scans, what do you do with them? Do you go, oh, I've got this scan run, and now I'm going to raise a ticket, or I've got this report, and I'll look into that, or raise a risk, or do these things last for a day or for a few days? Or sometimes you're like, oh my goodness, we haven't run this for a few weeks, and now we're getting to the end of the project. Quick, run a scan, see how it goes. And then, oh my goodness, we're going to spend days going through these vulnerabilities, doing patching, doing retesting, doing refixes, and then finally, it's all sorted out. And so that kind of approach to your security can really slow down your work and impede your velocity. So what we're doing now at the ANZ is we're using the vulnerability scanner in Google Cloud, but we're using it in every build that we do. So we see here, we have our source code. Our source code moves into Cloud Build and does all the usual things we do in a build, but at the same time, we run that vulnerability scan. And what happens is, if that vulnerability scan fails, then instantly we have a red build, and a developer can go in, have a look at that, find out what is the issue, and it'll highlight for you the severity, it'll highlight for you which package is impacted by that, and you can go in and you can do the patching or remediation, whatever is required, and you fix that. So you find that problem, you fix that one small problem, and then that's resolved, run the build again, everything's green and everything's fine again. And so instead of taking this huge amount of pain down the end of weeks of your work and slowing down, we just take these little increments along the way. When we find these things as they occur, we fix them straight away, and that helps us keep that velocity moving as we're working in our development. And so that's one way that we're approaching security. The other one is binary authorization. So we've looked at kind of the left side and that CI process. Now we need to move on to the deployments. So as we move our deployments through, how are we doing the enforcement of this security? Because you may have lots of security applications, because that's the when we scan things for vulnerabilities, that's one process we have, but we have lots of other security tools, lots of other test processes, maybe you have performance testing. How are you gathering that information and making sure that it applies to that binary that you're moving into your production environments? Because if you have security and you have lots of reports and you leave those reports stacked up in a big pile on your desk, that's not helping anyone. What you need to do with that information is enforce that. And so binary authorization is a way to enforce your security. Now, I will talk about it a little bit, but maybe what we'll do first is we'll do a little demo and have a look at how this applies. All right, there's no shortage of laptops today. All right, here we go. So, this is a simple demo. What we've got here is my 2 images in my container registry. And now by looking at those images, you tell me which one has passed all of my testing and all my criteria and which one has not. And the answer is you can't tell, just so you know. But what we're going to find out. So what we're going to do is we're going to grab the business processor and we're going to deploy it. Bam. One button, deploys. Yes. And then we're going to hit refresh and we're going to look at our cluster. And oh my goodness, that was the wrong one. So what we see here is that this has been forbidden by a policy that says this image has not been approved. And so the way this works, binary authorization sees your image comes in and it looks for an attachment that's attached to this. So it's a way to attach a certificate to say this has passed our policies and we have a certificate to prove that this image is okay with us. And in the case of this particular image, that image is not okay and it should not be deployed to our environment. Now, don't worry, we're not going to leave it with red. We're going to have a look at Business Orchestrator, that's our other image. I'm going to press a button, Orchestrator, I'm going to press that button, magic's going to happen. Yes. Hit refresh. It's a perfect demo. So, green lights, everybody. We're all happy because this image actually has that certificate attached to it. Binary authorization reads it, it says this is past your policies, you are cleared all the way through and you've got a big green light for that. And so the way it works is, imagine this, you have an internal audit team and they come to you and they say, we need to understand your controls, we need to understand your policies, so what we're going to do with you is we're going to set you a meeting for a couple of hours and we're going to read documentation together and we're going to understand how your policies work. You're like, well that sounds like a lot of fun guys, but how about we do a demo? I've got an image here. This image has been approved by nobody. It's been tested by nobody. And really, I don't even know where it came from. And I'm going to deploy it to production. And then you jump into production, and you press the deploy button, and you show your audit team, look, this cannot be deployed to production. We don't just talk about security here. We enforce our security. And so we make sure these things can move through because they're approved. Now, when I've done this demo, I just did that with the one attester, the one policy. But you can have a multitude of policies that you may want to apply and do that for different clusters depending on how you've set up your organization. So imagine in one cluster, you're like, all that has to happen here is we need a peer review. That's all we need. You can deploy to this cluster. The production cluster, maybe you want a peer review, maybe you want to pass a certain phase of testing, and maybe you want to add to that there's a team or even a person, if you choose to, that is a part of this. And so if we go back to the slides now, we can see on the left side, we have our vulnerability scanning, we're testing this thing straight away, and then as they move through to deployments, we're making sure that we have just those trusted images that move through, and they're deployed to our engine. And because this is all a pipeline, so we have security, but it's moving through with automation and with the speed that we have available from this automated pipeline. And so at the ANZ Bank, that's how we're applying these 2 principles to make sure that we move with security and all the things that we need, but moving that security forward with speed and reliability. So thank you. Back to you, Pali.
So we talked about how we can increase developer productivity with cloud code. We then talked about shifting left, especially on security with cloud build. Now let's talk about how you can scale your operations. This is one of the huge benefits of cloud and why all of you are adopting cloud today. So as we think about scaled operations, my mind goes back to Google, because We've got 8 products with over 1 billion users each. And as you saw during the keynote yesterday, Urs shared a study that showed that of all of the major clouds, Google Cloud was the most reliable. And much of that is because we have internally in Google an amazing SRE team that helps us scale and operate all of these Google products and of course Google Cloud as well. And for the last 15 plus years, there's been one person at the head of that team. So I'd love to welcome on board Ben Treynor, who's been leading our SRE team for the last 15 years for a fireside chat. Ben?
No pressure then.
So, Ben, we talked about all of these billion user services.
Yes.
I wonder how many folks in the audience are using billion user services every day?
Well, I suspect, probably a few, but it's one of those interesting myths. You say, well, SRE, isn't that for only the really, really, really big services? And I think we maybe have an opportunity to talk about that a bit, but certainly, I started the SRE team a little, as you say, 15 and a half years ago now. Google was not that big at that point, and in particular, some of the services that we were running were actually fairly modest in size. And we've found that we have a set of principles and practices that we can use across services at pretty much any scale, and we found that they helped.
Yeah. So Ben, as you think about these SRE practices, could you share a little bit more about what those are?
Yeah, absolutely. And I think you have a slide up here that talks about a study that was it Forrester did recently about SRE practices and said essentially, can these be used by anybody, or do you need this huge monolith of code and engineering support? And they found that roughly half of them did not need this. But let me talk about a few of the SRE practices that I think are usable and applicable to pretty much anybody who's running a service. The first is one that we talked about a bit earlier, which is having SLOs. And SLO is a pretty dry term. It stands for service level objective. And the number of people who get excited about service level objectives, it's modest, let me assure you. But what SLOs really mean is you want to be able to measure what your actual end user experience is, and you want to have an opinion about what performance would be sufficient for most of your users to like your product. We actually internally call them happy SLOs. It sounds very cheery, but it's a very simple concept, right? Measure your application the way your end user sees it, and have an opinion about what the end user would need to see to be happy. Sounds really easy. It's actually usually fairly hard in practice. Most applications don't actually instrument what the user sees. They instrument some things that are along the way and say, well, good enough, right? And what we've found in SRE and in running Google services is actually that last mile of instrumenting the common activities that users are actually doing is really important. Oftentimes, the behavior that they see isn't what you think, and the instrumentation that you do on intermediate steps doesn't actually tell you about some of the problems that you've got. And so I like to differentiate and say, like, there's black box monitoring, and black box monitoring is what your happy SLOs eventually should be looking at. Now, as we saw earlier, if you're on call and the monitor says something's wrong, you want a little more information than that. And so in addition to that, you'll clearly have SLOs for internal microservices and SLOs for intermediate steps and so on. But the most important thing is instrumenting the end result, because after all, that's the only thing your user sees, and really it's the only thing that they care about. And that's something that you can do right away. In fact, really it's easier, trust me, to do when the application is small than when it gets bigger. So another concept that we use that really sort of applies to everyone is this concept of error budgets. And an error budget sounds like a very sort of odd thing. If you've read the SRE book, it probably seems less odd, but it's an important concept in site reliability, which is that our goal is actually not perfect availability. Because number one, right, your users are using, a device, maybe a laptop, maybe a phone, maybe a computer, which is not 100% reliable. They're communicating with your service over a network, which is not 100% reliable, et cetera, et cetera, et cetera. And so the difference between, let's say, 5 nines and perfection is probably not distinguishable by your users because there are so many other things that in the path that will also break their experience. But the engineering cost of the difference between 5 nines and perfect is immense, and its drag on your feature velocity is immense. And ultimately, you're running a business, you're running a service, and so these two basic goals, I want a service that's reliable, but I also want high feature velocity, I want to be able to launch new things that my users want, is really important. And error budgets is the concept that lets you bridge those two. And it's really fairly simple. If your availability target is 4 nines, then your error budget is that last 0.01%. And you can spend it on silly errors, right? Pushes that shouldn't have been made, features that basically don't work, or you can spend it taking calculated risk, right? Exposing a new feature to 0.01% or 0.1% of your users for 10 minutes and measuring the result. And if you have happy SLOs, you know whether it worked or not. This lets you have very fast feature velocity because you can take a small risk, look at its effect on your SLO, and decide whether you want to make that a larger risk or not. And it also helps the SRE team or your operations team agree with your development team. Should we do this? Well, are we out of budget? Yes or no? If we are not out of budget, let's go ahead and launch it, right? We have budget to spare. And if we are out of budget, okay, data says we're not making sufficiently prudent or careful choices, we should hold back and spend a bit more time on availability. Blameless postmortems. Somebody mentioned it earlier when I think there was a hiccup in a demo. This is an SRE practice that's actually pretty easy for everyone to adopt, and it's not, not a complicated idea. Again, in theory, harder to implement in practice. But the basic idea here is you've hired good people. You have a recruiting process to identify people who are intelligent, smart, well-intentioned, and despite all of that, right, despite these people doing their best, something went wrong. Look at how your system works and figure out how you'll make it less likely for the system to break, easier for the people who are looking after it to fix it when it breaks, and make those the goals of a postmortem, right? Figure out how to make it more likely to succeed next time, despite the fact that there are going to be people working on this who are intelligent and well-intentioned and imperfect. And then finally, capping and eliminating toil. This is actually, it's better if you start this at a small scale, but this is the idea that every system, as time passes, requires more and more things that need to be done by hand because, we were in a rush, you needed to get that feature out the door, and there were a few bits that weren't fully buttoned down, but we can deal with them later. My experience is there is never the later. Right? There's only the now, and by the time you finish that feature, there will be the next round of features that you're already slightly behind. So, get rid of that fantasy, and instead say, toil, human work to do something where that work does not make tomorrow better, you'll just have to do it again. Toil is another budget that you have to manage. And in SRE at Google, we say toil is capped at 50%. You can't have the team spending more than half of its time on sort of non-repeatable human actions to support various interesting features and snowflakes and so on. And the rest of the time has to be spent making the service better, building production infrastructure, et cetera. And once you view it as a budget, then you ask the question, well, where am I going to spend my toil budget? And it'll be on the things that are brand new and hard, where you don't really know exactly how to do them automatically yet. And then you'll have a fraction of your development time that's spent implementing and deploying projects that get rid of toil in the places where it's now easier. And that cycle kind of continues forever. But it's important to keep this as an explicit budget, and it's important to actually watch to make sure your teams don't spend too much of their time on toil, because there's only two options, right? Option number one, your service is not successful, your business goes under, and none of this matters, right? Option two, your service is successful, it grows, and toil typically grows roughly linearly with the size of your business. So if your team is 50% occupied with toil right now and not doing anything to fix it, and your business doubles, guess what, right? You're going to be hiring a bunch more SREs. Not a good plan. So this is, in some ways, a plan for success, and it involves a certain amount of continuous investment, but it absolutely is the right path if you plan to be successful.
So Ben, as I talk to customers, the first thing they tell me is like, they love this concept, they want to implement all this, but they're worried it'll take them a lot of money, cost them a lot of money, or they probably need new people So how do you respond to that?
First, I laugh. So, you know, as I tell people, I'm actually a software engineer, right? This is the first operationally oriented role I've had in my entire career. I started out in enterprise software, interestingly, at Oracle, when they were a little 400-person company. Who knew? And you don't actually need new people to do SRE or to do DevOps or to do these practices. In fact, you should have people who are engineers and who consider themselves software engineers and who will be bored to tears if you ask them to do the same thing over and over again, because they have the right mindset to say, how do I make a machine do all of this boring work, this repetitive work, this vigilance work that people are actually quite bad at, so that I can get on to doing something that's more interesting. And that's a great motivation. These practices then give them guidance on how to do that effectively. You definitely don't need new tooling. I mean, all of the things that we've described here, like what you have now in cloud is way better than what we had in SRE in the early days. And in fact, a number of the systems that we have here have been influenced by what people have discovered in DevOps over the years. And yes, this isn't just for cloud native, right? These same rules of physics essentially apply to any system. I will say that services that are running in the cloud definitely have it easier because, as you've just shown, you've built a bunch of the things into cloud that we had to build ourselves. But the open source community, if you're still running things in-house, the open source community now offers a lot of these systems for you as well, and I would definitely take advantage of them.
So as I talk to these customers again, the other common thing I hear is, hey, we've already got a DevOps team.
Yep.
Right? So do we need to now create a second SRE team?
So the good news is no. I've gotten this question a few times over the years because I coined SRE back in 2004, and there was DevOps at that time as well, but both of them have emerged as industry, let's call them tracks since then. But SRE and DevOps are not different. SRE is a particular instantiation of DevOps, but nothing more. And if you actually go through and read what the different branches of DevOps have to say about how systems should be managed, how services should be monitored, et cetera, they're very similar to what SRE does. I simply would say SRE is a more specific implementation of this general class of DevOps. It's worked well for us. It doesn't necessarily have to be exactly the recipe that everyone follows. It's not the only path to success. But I would say these two are very much complementary ideas. And in some places, I expect the folks in the broader DevOps community absolutely will come up with a superior approach, in which case we will adopt it. And we have written now 2 books in the SRE team covering our specific implementation. And again, I think those are useful for folks to understand what we did and how we did it. They don't necessarily have to be adopted wholesale by other teams.
Yeah. So Ben, could you actually share with the audience what are like a few things that they could just start doing tomorrow?
Yes.
Right, to
right,
adopt SRE.
So interestingly, when we wrote the first SRE book, that was one of the principal questions we got back is, okay, this all sounds great and these are interesting stories, but how do I turn this into practice? And so we wrote the second book in part to answer that question, and if you have the time and energy, I definitely recommend reading it. We put a fair bit into it. But let me give you 3 that you can do kind of today or immediately that are 3 of the most important practices, I think. The first is to actually write down those happy SLOs we talked about. It is perhaps unsurprising, but still surprising how few SLOs actually get defined and monitored, and how often what you find is what we've monitored is the thing that's convenient versus the thing the customer cares about. And then over a series of outages and postmortems, you eventually migrate. So you can skip that whole step, right, and go directly to sort of the great end result if you take the time to write down the SLOs that if you just barely were meeting those things, most of your customers would be happy. And then dog food them, right? If you use your product internally, and you should, try making your internal instance of your service operate where it's just barely meeting those SLOs you just wrote and see whether your internal users are happy. And if everyone's more or less, seems slightly sluggish, but it's okay, you've got a good SLO. If everyone grabs their torches and pitchforks and comes to your door, you may want to revise, right? Secondly, we talked about toil. Toil it's like technical debt, right? Except it's much easier to measure. And my recommendation is, look at your sources of toil and just pick the one that's the highest ROI, right? It's easy to fix. It occupies a lot of people's time, maybe because it gets done a lot. And start an engineering project to actually fix that, carve out folks' time. Because it gives you this great experience of now we've spent N months of engineering and we've gotten rid of N years per year of toil. Okay, now I see how the system works and we can have a regular review and sort of look for our toil and decide which ones are worth eliminating. And that gets you started on a path to avoid what we call ops overload, which you don't want to be in. And then finally, everyone has some production incident, right? Whether it was an actual full-blown outage or just something that didn't go well. Conduct a blameless postmortem. Try the approach of saying, let me assume that although humans will always make mistakes, I'm not going to focus on that because I don't actually know how to fix that in the real world, but I can fix how the system works. And conduct a postmortem where the conclusions are we should fix the following things in the system to make it less likely to fail, more likely to provide good diagnostic information when it does fail, make the failure less severe, make the failure shorter, and see if you like that result, because my prediction is you will.